Okay, I'm going to record for the people that are gone. We are on day 2 of the 8-1 notes and stuff. We did go through number 4 real quick to find out what your test value is. And this is what we got for our chi-squared value. Here's the formula up above here. But what I want to do before we go back to the notes and before we start doing anything more is I'm going to add to this and we're going to find out our hypotheses for each one, 1 through 4. All right, so here we go. You guys should have this test value done. You go shut that off. Haley, I don't know where it's at. You guys should have these test values done, but let's talk here like which one you're doing, okay? Claim. On number 1, it says most adults would erase their personal information online if they could. They had 636 randomly selected adults, which you should have down for your N, right? And they showed that 65% of them would erase all personal information. What is 65? That is P hat. 0.65 is P hat. Okay, what are we comparing to? What's like the P value?
Whatever those are.
Most, 0.5, right? We're comparing most. Okay, so we are claiming that most adults would erase, okay? Most means what? Majority, more than half, right? Okay, so we're talking about P, proportion over here when we're doing our hypotheses. Chase, you got to listen to this, okay? We're talking about proportion when we're doing our null and alternative hypothesis, okay? Our first hypothesis is always going to be equal. So we're always going to have it set equal to. And what are we saying it's equal to?
50.
Proportion is equal to 50%. But we are claiming majority, right? So we are claiming in our alternative hypothesis that it's more than 50. So our claim is going to go there. Now, your claim will not always go with the second one. If I was claiming that it was exactly 50%, my claim would go with the top. Does that make sense? Yeah. Okay. But my claim is going with majority, so that's how that would work out. And then I do all the number crunching and I plop it into this formula, and then we come up with a conclusion and we do the rest of it, okay, which we're not going to get to yet. Okay, let's just talk about our hypotheses here. Number 2 is claiming that fewer than 91% of adults have a cell phone. Okay, now, are we doing proportion, mean, or standard deviation if they say fewer than 91%? We're on a proportion again, okay? And what does fewer than 91% look like?
Less than 0.91.
Less than 0.91. What is less than 0.91?
Your P.
P, the proportion, is less than 0.91, okay? Now, where does that go for my hypotheses?
Above. It's a not.
Your H naught is always
It is always 0.5.
equal to 0.91.
Always equal.
Yeah, it's always equal to 0.91. Okay, my claim is that it's less than 0.91, less than 91%. This is what I am claiming. So my claim goes with the bottom one. Okay, then we crunch all the numbers, we do all the things, you plop everything into this formula, and we come up with an answer, right? But that's what my hypotheses would look like. Yeah, equals to 91% and less than 91%. Chase, this is your last opportunity. I just saw you do one of these. Put that away. Number 3, claim. What?
Why is that percent P and not the other one?
Oh, good question. Fewer than 91% have a cell phone. In a reputable poll of this many adults, so that means N is 10, 17, 83% said that they have a cell phone. That's P hat. Because P hat is my sample, and my sample was the 1,000. So 83% is what we're comparing to. Yeah? Yep, they are claiming, so that's P. Your claim is always the P value, okay? P hat is the number from the data that they give you, okay? Good? Okay, let's go down and do number 3. Now we're talking about mean pulse rates. So mean is up here, okay? What's the symbol that you use for mean for our hypotheses?
T.
Nope.
Mu.
Mu. I'm talking mu. Mu is either equal to something or mu is whatever, right? So the mean pulse rates in beats per minute of adult males is equal to 69 beats per minute. Okay? So let's fill in our hypotheses. Equal to 69 beats per minute. That's what I'm claiming is happening. I am claiming that the mean pulse rate is equal to. So here, my claim goes with the top one. I just said your claim is not going to always go with your alternative hypothesis. Now, what symbol do we use down here for 69% or 69 beats per minute? Mu is what in comparison to 69? The mean pulse rate, we're claiming that the mean pulse rate is 69. For a random sample, blah, 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 blah.
69?
It is not equal to 69. Yeah, because they don't say greater than or less than. we're claiming that it is 69. So that means my alternative hypothesis is not going to be equal to. Does that make sense? Okay, let's see about this last one. The standard deviation for pulse rates. Okay, what symbol do we use for standard deviation? Sigma. So I'm going to put him here and here. My top one's always equal to, okay? They are claiming that the standard deviation, I'm just reading this top sentence. The standard deviation of pulse rates of adults males is more than 11. What does more than 11 look like? Greater than 11. Where does greater than 11 go?
On the bottom.
On the bottom, greater than 11. This is what I am claiming. So I am claiming that the bottom one is true. Okay? The top one would be equal to 11. All right? Now, just to reiterate again, your claim does not always go with the bottom one. In the third one, our claim went with the top one. Got it? Okay? Then you run all the values and you find your test value, like in number 4, we found this test value here of 150.91. That is going to either lead us to say this is true and this is not true, or this is not true and this is true, right? That test value, which we don't know how to do yet, but that's what we are leading toward, okay? The last thing that I'm going to talk about today, before we do some examples up above, just again, is we have to now, relate this to a bell curve. I know that makes you really thrilled, but let's relate this to a bell curve. So this top guy right here, this is my bell curve for number 1, okay? They're going to talk about the difference between a left tail, a right tail, and a two-tail test, okay? So here's what happens. Here's my bell curve. Let's say I have a two-tailed test, right? It's considered to be an extreme value if it lives here or it lives here. So for example, when I talked yesterday about my blood pressure medication, right? Yeah, my blood pressure medication was effective. It was reducing my blood pressure a little bit. So it's a little bit effective, but is it effective enough? Does it live over here far enough away from what the average blood pressure was to say that it is actually doing a significant change, right? Significant things live here and here. Is it doing enough of a difference? Okay, so that's what we have to decide. Now, we have to look at a bell curve and we have to look at whether it's a one-tail or two-tailed test. And the thing that determines that is this guy. P is greater than 0.5. We are not looking at anything except whether he lives in this region or in this region, right? So this guy is a one-tailed test because we're only doing greater than, and this is going to be a right tail test, okay? Because we're only looking at the greater than side, true? Okay, let's go to the second one. If I do a bell curve here, will this be a left tail, right tail, or two tail?
That would be most, wouldn't it? So you.
P is less than. He's going to be a left-tailed test. Okay?
Does that make sense?
So left tail.
Because it doesn't say exactly 0.5. It's
Okay.
just most.
The third one. Left tail, right tail, two tail. Two tail, because I don't know if he is greater than or less than. I'm just saying not equal to. So he could live over here or he could live over here. So this is going to be a two-tailed test. Two-tail test. Okay? And then the last one, number 4. If we would put a bell curve on him, he is going to be
Right there.
right tail because he's greater than. So we're looking at this right tail. What's considered to be an extreme value there? Got it? Okay, let's go. That was a lot of extra stuff on this homework page. Woo! Okay, let's go to
Did you?
example 1 that we started yesterday. Okay, let's go to example 1 that we started yesterday. So go back to your notes. Example 1, here we go. Example 1 we started yesterday. You guys have stuff written down, but I'm going to go back through it again. Okay?
It's been 10 minutes.
Sorry.
Time's up.
Sorry, you guys are not listening, so I'm going to go longer. Ha!
What?
Don't lie.
What do you mean? You're just making things up.
Well, whatever. Example 1. Okay, we were talking about majority. Okay, majority means greater than half. Okay, so for my hypotheses, we're going to hypothesize that if we are claiming greater than half, that means P is greater than 0.5. This is my claim, and we're talking about drone deliveries. You guys have this written down. What goes in my null hypothesis, the one right above that? P equals 0.5. Okay, now, before we do anything else, we are going to figure out, is this a left tail, a right tail, or a two tail? Right tail. If we're looking at P being greater than 0.5, that means we're only looking at extreme values on this right side. So this is a right tailed test. Okay, we're looking at extreme values over there. All right, now, last thing that we're gonna do, this is up through like step 4, I think, or step 5. We're gonna calculate and do that formula real quick. P hat minus P, you don't have to have these memorized, but I do. PQ over N, okay? And we're gonna plop stuff into here. So based on this problem here, we were comparing everything to 0.5. That means P is 0.5, right? That means Q is 0.5, okay? In the last sentence here, in the parentheses, parentheses, it says a survey of 1,009 consumers. What does that mean? N is 1009. We wrote that down. Included 54% said that they were not comfortable with drone deliveries. P hat is 0.54. Okay, we're going to plop that into this formula and we're going to get a value for Z. So P hat, which is 0.54, minus P, which is 0.5, over the square root of, what's PQ? 0.5 times 0.5 over N is 1009. Practice typing that into your calculator, see what you get. 2.54. Isn't that centimeters to inches, the conversion? Yeah. Whatever, that means nothing. Anyway, okay, so that's your Z value, 2.54. Got it? 2.54. Okay. Here's what we're going to eventually end up doing. Everybody listen. Everybody listen. This is the important part, okay? Eventually, and this is the last part of the hypothesis testing. This is the important part, okay? 2.54 is the value that I got for 54%. This is like the Z score for 54%, okay? Now, 54% is pretty close to 50%, right? So am I going to say that 54% is close enough to 50% to say that they're equal, or am I going to say he's greater than 50% enough, right? Is he greater enough than 50% to say that it is a majority, right? Or is 54% a fluke? Because the next time we do a sample, we could end up with 49%, right? So is it close to 50%? Are we going to conclude this, or are we going to conclude that that no is bigger than 50%? What if it was 51%? Would you say equal to 50%, or would you say greater than 50%? Because I understand that 51% is greater than 50%, but is it always going to be greater than 50%? Or is it close enough to 50 to say equal to? Right, but like, if I would survey another group, would that fluctuate enough to be equal to 50%? That's what we have to decide, and here's how we decide it, okay? If your number is greater than 50%, it lives in this significant region, is considered to be significantly larger than 50%, and this is where greater than land lives, right? Okay? If our Z-score would land in here, we're going to conclude that it's equal to 50%. 54% is not high enough to say that's significantly larger than 50% to be a majority. Make sense? Ish. Okay? And the thing that determines that is, where does 2.54 live? Right? Does 2.54 live over here, or does 2.54 live over here? We would have to know this cutoff mark. And we do that by looking up the number on the chart. And that's what we're going to get to next week. Okay? That's what happens. All right? So that's how we lead, or we get to our conclusion. All right? Let's go through real quick, and let's go on. You guys have a page. Do you have a page on like the last page of this 8-1 notes that says example of hypothesis testing? It should be maybe the last page. Yeah, go to that. We're going to do the first 5 steps for this guy. And we're going to see how we do. Okay? Example of hypothesis testing. Chase? Pull it up. Okay, you got to listen. Example of hypothesis testing. Here we go. Data set 27. We're talking about M&Ms. They have, okay, data set 27, M&M weights in Appendix B list data from 100 M&Ms. Stop. N equals 100. That's what I see. 27% of those are blue. So we're looking at blue M&Ms. Who really cares? But whatever. That's what we're testing. All right. So what is 0.27? P hat. My sample had 27% blue. Yeah? Okay. Now we're going to get to the claim. Circle the word claim. The Mars Candy Company claims that the percentage of blue M&Ms is equal to, underline the word, equal to 24. Okay, so we're saying P is equal to 24%. Now, here's the deal. We're comparing these two things. That's what we're comparing. We're saying 27% is the number, the percentage of blue M&Ms that I got. They claim 24%. All right, so did I get a significantly high number of blue M&Ms, or do you think 27 is close enough to 24 to say, okay, you're fine?
It's
Do you
close
think
enough,
that's too many blue M&Ms if I had 27% and they claim 24%?
Riddle me this.
Or like, where's your cutoff mark?
Wait, how many different colors of M&Ms are there? Like 5.
but 3 more across 100 M&M containers.
Yeah, it's still 24% for like their company average. Like,
I don't know.
Someone's getting one of the colors is getting cut short.
Right, because it should be 20%, right?
Exactly.
It's
Right.
called
Unless there's
translation.
4 colors. Is there 4
There's
colors?
no way.
There's more.
There's gonna be more.
There's like yellow,
There's
red,
orange,
Yellow,
red,
green,
yellow,
blue,
black, brown.
Brown. The brown's another one?
6.
green.
I don't know. So maybe blue is just a more frequently colored one. I don't know.
I don't know.
Okay. So anyway, is
They're
27
secretly-
close enough to
it's all
24 to
pretty
say that
eliminated.
like that's okay, right? Or should we be mad that we have too many blue M&Ms?
I am. They should all have.
I don't know. That's what we have to decide. So, use an original claim to create a null and alternative hypothesis. That's what steps 1, 2, and 3 are. So, here we go. Our hypothesis and our null and alternative hypothesis. Okay, we're talking P here. And what are we talking for P? Put these down for steps 1, 2, and 3. Go.
I also keep out.
Okay, knock it off. H not H1. P is what? Null hypothesis. P is what? Equal to, which one? 0.24. Okay. Now, it says the Mars Candy Company claims that the percentage of blue M&Ms is equal to 0.24. So my claim is going with the top one. Claim is going with the top one. They're claiming that it is equal to 0.24. So what's my alternative hypothesis? Not equal to 0.24, okay? So when we do this, when we do a bell curve, is this going to be one-tailed, two-tailed, left-tailed, right-tailed? What we got? Two-tailed. Quit it. Two-tailed, because we have equal to, not equal to. And then I have to decide my 27%, does it live here? Does it live here? Does it live in the middle? Whatever. Like, we have to decide that, okay? But let's follow the steps. So select the significance level. What's my alpha level? They tell you.
0.05.
0.05. That's my significance level. We have to have that. That is kind of like saying a 95% confidence.
Oh, so you got 1 minute.
Okay? 95%. I'm almost done. 95% confidence, okay? That we're going to use later on because that will tell you, that 95% confidence, that will tell you where these marks are at.
Are they going to tell you what it is in the
They have to tell you. Yes. They have to tell you what you're using, okay? And then step 5, identify the value of the test value. So our formula for, it's called Z. Formula for Z is P hat minus P over square root PQ over N. Okay? And we have to plug in our numbers and see what we get for our test value. And then we'll come up with the conclusion later on. So what's P hat? 0.27 minus 0.24 over. So looking at those two numbers, I know my Z value will be positive, right? The square root of PQ. P is 0.24. What's Q? We didn't say that. 0.76, okay, if 0.24 and 0.76. And then what's N? 100. Okay, so we've got that going on. Let's figure out what our Z value is.
Can I have my calculator back?
Oh, yeah.
Don't throw it. You could hit me.
I was scared I was going to hit Luke on the way up with the calculator. Okay, what do we get? 0.70.
Gunk.
Yeah?
Yeah.
0.70? I did that in my head. 0.70. So, that's where we're going to stop at. But going forward, we have to decide, does 0.70, does it live here? Or does it live in the middle here? It can't live on the left side. How do I know it doesn't live on the left side?
He's greater than 0.
0 is the middle, right? Okay, so my Z-score of 0.70, does it live here or does it live there, right? That's what we have to decide. And that tells us which one of these we go with, right? And that is all right? So, here's what I want you to do for homework.
No.
Oh, man, you only have 2 problems. That's it. 2 problems. 2 problems. And that's not even whole problems. So, here's what I want you to do. Number 5. Number 5. Is that us to go? Okay, wait, we'll do homework tomorrow. I guess if you're watching this video, here's what the homework is. I'm going to have them do number 5. I'm going to have them do The hypotheses based upon the information that they give here. So fill out what your hypotheses are. Label if he's left-tailed or right-tailed, and answer whether he's left-tailed, right-tailed, or two-tailed. You can circle it if you want to, whichever one of those it is. Okay? Do that for number 5, and do that same thing for number 6. The hypotheses, tell whether he's a two-tailed, left-tailed, right-tailed, two-tailed, and then label your tail. So if he's right-tailed, just shade one of the sides. Okay? Whatever it needs to be. Okay? That's 5 and 6 hypotheses, labeling bell curve, and part A. That is all.